Okay, so this one basically what's happening is which transformation does not? So these are all different transformations. Does not produce a square with vertices of the same set of coordinate pairs. Basically what it's saying is if I do something to it, let me just draw this out on top of it. If I do something to this figure, that it doesn't wind up back in the same spot. What does that mean? So say I get this figure and I rotate it. You see how it winds up in the same spots? I rotate. You see how it winds up in the same spots? They don't want that. They just don't want that to happen. They don't want it. So if I flip it over, and you see from the y-axis it's 2 up, well then it would wind up 2 down. It would wind back here. So they don't want that. Basically, the way it would not wind up on the same vertices is move it to the left, right, just move it. And what this one says right here, move it to the left and move it 2 down. So the vertices are totally different, unique ones. So that's the answer for that one. Okay, so let's see what's going on. This one here, Desmond wants to pay 10 of college. That cost $50,000 for the first year. Desmond's family has raised $6,000 and he has applied 1,500 scholarships. He has applied for that for a month of tuition. The time was set aside a fixed amount each month for the next 12 months. How much should Desmond save each month for the next 12 months to have enough to pay for the first year of college? Desmond wins a scholarship. His family needs to, let me see, this is the way this one goes. I want you to draw a whole big picture, a whole box, and that is going to be 15,000. He has saved, okay, they saved 6,000. So out of all this, less than half is already gone. So minus 6,000. That's this side over here. So this other side over here is what, 9,000? And he has applied for 1,500 scholarship. Okay. It doesn't win the scholarship, so it means if he wins it, he doesn't have to pay that 1,500 either. That gives him 0, 0, becomes 8, 10, 5, 7. Okay, so 7,500. That they have to pay. We'll take away this 1,000 right here, 500. So this part over here is 7,500. So that's how much it is. So on that note, we're going to go 7,500 is 7,500 and divided by 12. Because we're going to save it for what? The next 12 months? If he does not win a scholarship, then he's over here at 9,000 divided by 12. So let's see what this works out. 7, 5. So this will be 625 here. Not, it's 9,000. And we divide it by the 12 months, and it'll be 750. So 625 here, and 750 here. So this one, I didn't know. I don't like the reading. I don't like the way it goes, but this is the way it goes. So this is the right triangles. We want to go ahead and set up the proportion to work this one out. So we're going to go with an R to S and R to T. So R, I want to say it's R1, which would be the coordinates of negative 11. And 6. So give me x1, y1. I'm going to go S to S. S would be negative 6 and negative 1. Negative 6 and negative. So we're going to go x2, y2, and the format is y2 minus y1 over x2 minus x1. This is on reference material. So we're going to go with 6 minus a negative 4. y2 minus y1. Oh wait, y2, my bad, is way wrong. y2 is a negative 4 minus 6. Oh, that doesn't match up at all. So they actually just switch them around. So you can actually just switch these around. So you have, instead of having like that, we're going to switch them around. Put this as x2, y2, and we'll put this as x1, y1. We'll switch them around. I'm going 6 minus a negative 4. 6 minus a negative 4. Check, check, check. Oh, this is okay. So now it's going to be R and T. R and T. Hold on. Okay, so here they're going to say R and T. R, again, is this one. Negative 11 and 6. And T will be negative 9 and 2. And I don't even know which to switch. They're starting off with a 2, 2, 11, 6, 6, 6. So you can start off with either one. So I go with 6 minus 2. 6 minus 2, 6 minus 2. Over, we have to go over here. 6 minus 2, we're going to have to start off here. And go to negative 9 minus negative. So then we start off with a negative 11. So we're going to switch out the top. So we're going to 2 minus 6, negative 11 minus negative 9. 2 minus 6, negative 11 minus a negative 9. So there's the answer. Again, it's because you can switch. What does he mean? So if I calculate this slope from R to T, I can go rise and run. But if I go from T to R, I can go rise to run. And I still have the same numbers. I still get the same slope. Okay, so this is saying which of these has to be proportional. I don't even know what to tell you. Two different ways. I'll show you that I think the best. Okay, so on this note here, you want to basically get the calculator. And I would go to distance spreadsheets. For it to be proportional, it goes through the origin. So your B would be 0. So I'd go to distance spreadsheet. And just type in the numbers that are nice and neat to work with. Okay, so I'd go with 3 and a 10. Let's come over here and go with a negative 4 and a 35. And then, of course, you go to menu 413. Sam, behave, Sam. Ah, you did come on the video. So after that, press enter, enter, and look for your B. That is not, so I'm going to go to this one over here and change the numbers. So the 3 goes to a negative 1. And now we have a 6 going to a negative 2. Ooh, that's a 0 right there. That is a 0. That's basically like your scientific notation. And that means you have a negative. You have a decimal. You have a decimal, and it goes like scientific notation, 15 to the left. 15 zeros. So 0.1, 2, 3, 4, 5, 6, 8, 10, 11, 12, 13, 14, 15. So crazy. Let's see if it doesn't give you a 0. So I just checked the other two, I forgot to record it, but yeah, they don't give you a 0. I don't know why that's happening, but that's just where it goes. So on this right here, it's a square wall, I'm sorry, and I told you if you have a square wall on the actual side length, basically the square, the inside is 182, you basically get out here and get the square root. Okay, now it's going. So without reading it, basically all you do is get the square root of that number, 182. And so we get the calculus, square root of 182, if my pen wants to work. New thing. Square root of 182. About 13.4. There it is, about 13.4. Now, yeah, about 13.5. Perfect. This one's here asking about which is make it a function. Okay, so which ordered pairs can also be placed to this function, okay? They wanted to make it a function. or keep it a function, since x don't repeat, we want one where the x's don't repeat, so we put a negative 4, 3, guess what happens? It's no longer a function, so that can't be it. We put a negative 2, don't you see that negative 2? No, can't be it. We'll go with a 4 will fit there, the 4 does not repeat, so it is also a function with that one, check. 6 is also there, and I think this is a 9, 9, 8, so the 9 does not repeat. That point and this point added to this table will make it, or will keep it a function. Okay, so next one here, without even reading it, you don't ever kind of, in my opinion, I've never seen one you have to read, but in this situation when you have two lines, it's right here where they cross. So negative 4, 5. Wait, negative 4, sorry, 4, 5. Okay, so on this one here, all these numbers are kind of like, not weird, but you just got to kind of figure them out, and it's equal to a negative 13. I think that's the real question here. Okay, it gives you a lot of information, but it is going to be that negative, the square root of 169 is not that. It is equal to that. It's not equal to that. And it's not equal to that. It's actually, and an integer is a whole number, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and its opposites. So negative 1, negative 2, negative 3, all those also. Okay, so this one's going to be talking about yada, 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 simple interest rate. So then we're going to have an I equals PRT, and the interest, right? I is interest. Principal. I think I did that, yeah. A rate is also a percent. You know, I'm just going to tell you what I tell you. This is a big money, a big number. This one's a percent, and term has to be in years. So I equals 10,500 times a rate of 1.2% at the end of years. I think that's at the end of each year. And so what you can basically set it like that. You can do and solve. I just set it like this: 10,500 times your rate of 1.2% to the term of 1 gives you, and it says how much interest. Remember, the whole thing here was I equals to the principal times your rate times your term. Interest is equal to 126. Interest is the extra stuff, the additional stuff, okay? Just getting this one and reading it barely. Rectangular, yada yada, going through vertices is original. Dilation. So dilation, guys. So anything with multiplication. So this one's good, this one's good. These are multiplied. Out, out. Remember, dilation means to multiply. Okay, so get rid of these. Next thing is, look at this. These are the original one, and then it became this. Just look at this. 12 became an 8, and a 9 became a 6. They got smaller. So without this one, this is a bigger than 1. So the scale factor on this one is equal to 3/2, which is greater than 1, which is no bueno, because we won't want to get smaller. We want the scale factor on this one here, which is now 2/3, to be less than 1, which now gives us a reduction, or a smaller one. Okay, we're going to go stop there.